So in this question, we have a rectangular field. We want to split it now into 6 equal sections, and we have 420 meters of fencing available. So let's look at what that would look like. So I've got my rectangular field, and I want to split it into 6 equal sections. So I need 1, 2, 3, 4, 5 different widths to split it into 6 sections. So I've got W, 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 and W, an entire length and a length. So my isolating equation is the one that has the answer. So that's the perimeter of 420. So if I went around this, I would do a width, a length, a width, and a length. And then I would do all of my dividing sections as well to separate those into different sections. So I would have a width plus a length plus a width plus a length plus 1, 2, 3, 4, 5 more lengths to separate it into 6 sections. That altogether will equal 420. Or, combining my like terms, 5, 6, 7W plus 2L is equal to 420. So I'm using this as an isolating equation because I want to isolate for one of my variables. So first thing I'm going to do is I can either divide everything by 7 or divide everything by 2. I'm going to choose 2 because that goes nicely. 7 divided by 2, 3.5W plus L equals 210. So to isolate, I'm going to isolate length by subtracting 3.5 width from both sides. So I will subtract 3.5 width here and be fair and subtract it here as well. So length is equal to 210, take away 3.5 W. So that's my length. Now let's go to my substituting equation, which is my maximum area. So maximum area, length times width. So we're only allowed one variable, which is why we isolated for length. So my new length is 210, take away 3.5 W, and we'll multiply that by W. So distributive property, I get that my maximum area, 210W minus 3.5W squared. Or let's just write that with our W squared first. My maximum area, negative 3.5W squared plus 210W. So what I want to do is complete the square for that. So first thing I'm going to do is factor out a negative 3.5. So negative 3.5W squared divided by negative 3.5 is just W squared. And then 210W divided by negative 3.5 will be negative 60W. And then I'll leave myself some room. So up in my grid here, I put my W squared here. I take negative 60W and divide it into 2 equal pieces. So now I'm ready to factor by GCF. So in my first row, my greatest common factor is W. In my first column, my greatest common factor is also W. I take out my leading coefficient of negative 30 and take out my negative leading coefficient of 30. Now let's just check to see if this is right. W times W, W squared. W times negative 30, negative 30W. Negative 30 times W, negative 30W. So what will complete the square is negative 30 times negative 30, or 900. So I'm going to add 900. As soon as I do that, I've changed the question, so I have to also subtract 900. So 900 take away 900 is 0, and I can add 0 to any single equation or expression without changing its value. So I have negative 3.5 on the outside, and let's complete the square of our perfect square trinomial, which from the grid I know factors as W minus 30 times W minus 30, or W minus 30 squared. And to finish this off, I just have to do negative 3.5 times negative 900, that comes out. So negative 3.5 times negative 900 is positive 3,150. So let's write our vertex. Opposite of the inside, 30, straight up on the outside, 3,150. So remember, this is what your max or min is. This is when your max or min occurs. So because A is negative, I know I have a parabola that opens down, meaning I have a maximum, which is what I wanted. So my maximum area is 3,150 meters squared. And when does it happen? Well, I had a variable of W. It happens when W is 30 meters. Now let's go up here and figure out the length that goes with that. So remember, length was 210 minus 3.5 W. So length is 210, take away 3.5 W. So length is 210, take away 105, which means my length is 105. So go back down here, and my length is 105 meters. Let's make this all together so you can see the whole question. And it said determine the dimensions. So there are the dimensions right there, which of the field which can be fenced off to provide a maximum area, and that is my maximum area.